Logarithmic functions. The inverse of any exponential function is a logarithmic function. If we needed to find the inverse of a x or 5 to the x, which is an exponential function, we know we have this as our original function, then you got to switch x and y. Up to this point, you have not been exposed to any way to be able to get the exponent, which is y, on one side by itself. So that's where we need to use a logarithm. A logarithm allows us to be able to solve it for our exponent. Here's our definition of a logarithm. Here we have our exponential form, which is very similar to what you have up here in the red. And here we have the equivalent, meaning the same thing as our exponential form, but this is referred to as a logarithmic form. You'll notice here we were trying to get our y by itself, which was in the exponent. Now y is by itself. We would read this on the left as y equals log base a of x. This definition of a logarithm is one you're just going to have memorized. It's important to note that the a, the blue a in each case, always has to be positive. Also, the blue a cannot be equal to 1. The x right here has to be positive, where your y can actually be any real number. It basically boils down to whatever is after your logarithm has to be positive. And so whenever we're referring to that, you want to think of your a and your x. They both have to be positive. So we want to use our definition of a logarithm to rewrite this. Now, for the most part, all you want to do is you want to take your 8 right here, swing it over, and then it hits the 2 up as your exponent. When you swing your 8 over, the log drops. So we get 64 equals, and then it would be 8, and it hits the 2 up as the exponent. Both of these statements are identical in meaning. You're more familiar with the exponential form. You know that 8 squared is 64. Over here, we'll do the same thing. We'll swing the 16 over, hits the half up as your exponent. And when you do that, your log drops, and you should realize that 16 to the 1/2 is really the square root of 16. That is 4. And we'll continue to do that. We'll take our q, swing it over, hits the t up as the exponent. And then we'll go ahead and we'll swing our base here over. Here, our base is this. We're going to swing it over. Your exponent, when it gets moved up into the air here, needs to apply to the whole thing. So we're going to have parentheses around that. And then your log drops and it equals what's after the log. Here we're just doing the reverse process. We're putting it from the exponential form into the logarithmic form. Right now we have our base being the 27. Your base is whatever your exponent is on. So you're going to go log of your base. Your exponent goes over on one side all by itself. What was over there goes after your logarithm. So your exponent of 1/3 goes on the other side all by itself. You go log of your base of 3. So log base 27 of 3 is equal to 1/3. Go ahead and try to work out the next couple here. So we go log of our base, which is 10. Our exponent goes on the other side all by itself. The 100 goes after the log. So it'd be log, log base 10 of 100 equals 2. Here we would have log base x of 12 equals a. Here we would have log of your base, which is a plus b. We don't really need to have parentheses around the a plus b because they're both written as subscripts, so they're assumed to be written together. Your exponent, once again, goes on one side all by itself. So we're going to have log base a plus b of your 84x plus y equals 7x. So now we want to evaluate these. The first one, yes, you could use your calculator, but the rest of these you can't use your calculator with. You may want to think about what does this really mean? Well, this means, the first one, log base 10 of 1,000 means 10 to what power is 1,000? So that's what it means. For each one of these, you should probably think about what does it mean, and then go ahead and try to answer the question. So 10 to what power is equal to 1,000? And in that case, it's 10 to the third power. So your answer is 3. So for each one of these, think about what it means and then answer the question. For this one here, it means 2 to what power is 8? And that is also 3. This one over here means 9 to the what power is equal to 3. And in that case, it's to the 1/2 power because 1/2 is your square root. The square root of 9 is 3. When we are looking at this one here, the answer is the empty set. There's two ways to look at that. One of the ways to look at it is 8 to any power is never a negative. 8 to a positive power is positive. 8 to the 0 power is 1, which is also positive. 8 to a negative power is also positive because 8 to the negative 1 is positive 1/8. Another way to look at it is whatever is after your log is never negative. So then it's the empty set. Here, on the other hand, it means 8 to what power is 1? And that is 0. So some properties of logarithms. Remember, this means a to what power is 1, and while that is 0, this means a to what power is a, and that is 1. The next one means a to what power is a to the x. Well, the only way a to a power can be equal to a to the x is if that power is x. So basically, as we're looking at this here, your log base a of a undo each other, leaving you only with your exponent. Here, your a to the log base a once again undoes each other, just like in the last problem, and it leaves you only with x. Here we have a log on the left, log on the right. We have the same base. So if I said log base 5 of x equals log base 5 of 7, you would probably say, well, x has to be 7. That's basically what's going on here. If you have a log on the left, log on the right, they have the same base, then what's after your logs also has to be equal, and that's what we're saying here. Sometimes there is no subscript written after your log. If there's no subscript written after your log, it's referred to as log base 10. So log base 10 of x could be written as just log of x and mean the same thing. When there's no base written, it's assumed to be a common logarithm, which is base 10. We also have natural logarithms. A natural logarithm is log base e, the natural number e. Instead of writing log base e, we write ln. Whenever you see ln, it's just log base e.